Hi everybody, my name is Michele, and this is Lukas.
Hi, nice to meet you.
We come from Zurich, from Google, and we are here to present about CSP, which is Content Security Policy, and we'll say what it is, how to break it, what's the current status of CSP, and also how to make it better, how we are trying to make it better. Yep, that's us. We work in information security team at Google in Zurich, and we are in a special focus area which aims to solve large classes of vulnerabilities by mitigations. In this case, mostly cross-site scripting. So we're focusing on web vulnerabilities. So yeah, as I said, first we talk about what is CSP, then we dissect a policy and we show what's inside a policy. Then we highlight common mistakes, how to bypass CSP, and then we switch from like a destructive, let's say, hat to like a fixing hat, and we say, how can we make it better? And how we are already making it better. And if at any moment you have any questions, I would strongly encourage you to stop us and ask. I personally really like having questions, not just at the end, but also during. Okay? So what is CSP? CSP is a tool that web admins have to lock down their web applications in various ways. So it does not solve the problems, right? The bugs, the vulnerabilities you might have, but it's a defense in depth mechanism. This means that in a lot of cases, it is supposed to block exploitation. But not just that. And in any case, in no case should this be considered an alternative to careful input validation or output encoding. CSP is a pretty ambitious project, and the first aim is, as I said, to mitigate risk. So basically, you have a fine-grained control of what resources your web application can fetch, embed, and execute in the context of your web application, right? So this, for example, is important when there are markup injections by an attacker. You do not expect this kind of content to be in your web application, so you can declaratively say, I just want this content to be on my page. So if an attacker injects some content that you did not see coming, your web application would just refuse to load it, right? It can also be used to reduce privilege of the application, right? An important concept in security in general, not just web security, is the minimum privilege concept. So everything should run at the minimum privilege it should. So for example, you can sandbox not just frames, HTML5 added sandbox supports for iframes, but every resource you have. So you can, for example, isolate origins, you can avoid scripts to load in the same origin, and so on. And lastly, you can use CSP to detect exploitation because it has a monitoring mode and a reporting mode where reports are sent to an endpoint of your choice so that you can collect reports of violations, graph them over time, and have alerts or other types of monitoring and alerting systems. So CSP is basically an HTTP header. Actually, it's two headers. The first one is Content Security Policy, which is Content Security Policy in the so-called enforcing mode. So this is actually enforced. And the second one is Content Security Policy Report Only. You can add report only to just have it report the violations, but not actually enforce them and block the content, right? So this is useful basically only if you want monitoring and not also real protection. There are many CSP directives for different type of content. So for example, IMG SRC controls images, media SRC controls media, and then child, frames, plugins, styles, sheets. But we'll mostly focus on script SRC, because we are worried about cross-site scripting, which is the top web vulnerability, right? This is an example policy on the right. Default SRC is the fallback bucket, so basically everything that is not specified in a finer-grained way falls into the default SRC bucket. Self means the same origin. So this policy will allow content in the same origin. It will allow scripts in the same origin and from yep.com. And it will also send violations report to CSP violation logger in the same domain. You can also specify remote paths for reports and for everything. So here, for example, on money.example.com, you want to load an image of a cat, and you do image source cat.png. That is allowed because image source is not there, so it falls back to default source, and self is allowed. So it's the same origin. CSP checks it and says, yes, it's the same origin. Let's allow it. Then you also try to source a script from yep.com, which is explicitly allowed for scripts in the second directive, script src, yep.com. It checks it and said, yes, this is allowed. I executed. But if an attacker tries to inject markup like this, the usual reflected XSS, right? It breaks out of your markup, and then it says he wants to source his scripts from his attacker.com domain. So he does this, script src attacker.com. This is blocked because the source is not whitelisted. There's no attacker.com, right? And a report is sent to the CSP violation logger. What if the attacker tries to just inject inline scripts like this, normally, like script alert 42? This is also blocked because inline scripts are not allowed. There is a keyword for allowing inline scripts, which is unsafe inline, but this is completely defeats the protective effectiveness of CSP. So here I have a very, very quick demo for you. So here we can specify the content security policy. Can you see that? Oh, wow, it's really blurry for some reason. I don't know why. It's a little blurry. Anyway, here we specify the content security policy. And for example, this. With this, I allow just images on the same domain. So for example, if I add a cat image, which is on the same domain, it loads. But if I try to source something from evil.com, here, well, you probably can't read, but it said refuse to load the image evil.com cat JPEG because it violates the following content security policy. All right? Yeah. And here I am.
Cool. That was a pretty cool introduction. Before I continue with like the interesting stuff about like how to break CSP in general, I would like to know like how many of you guys have heard about CSP before? So just to go, awesome. That's great. That's really great. How many of you guys like tried to try to build a CSP for an application? Also great. Breaking CSP? Cool. Awesome. So I guess you will like that. The first part is easy, and the last section is getting more interesting, I guess, and hopefully has some news for you guys, for you guys as well. So like these properties are really interesting, right? So CSP as a mitigation has like a lot of potential. The possibility to maybe defeat XSS is really interesting. Unfortunately, most CSPs which they currently are on the web are like totally useless, right? We actually crawled a lot of sites, like millions, and really the vast majority is useless. I think this is mostly because people either don't understand CSP or they just not manage to, I don't know, refactor the page in a way that it could be used with CSP, right? So they still use unsafe inline or whatever. So yeah, it's hard to deploy. 2 examples, twitter.com and Gmail. this is just the script source part of the content security policy. Don't focus on the details, but you see it gets pretty long. It is super hard to come up with a superset that works on whole of all your, like for the entire domain, right? So you need to whitelist every other domain or endpoint you're sourcing scripts from. If you forget one, your site will break, right? It is really difficult, right? Also for the developer. So the other thing is, it's not only getting long. The more endpoints you put on the CSP, in the CSP script source directive, the more likely it is that your CSP is totally useless, right? We'll introduce that a bit later, but certain endpoints can be used to bypass the whole CSP like trivially. Is there a question? Probably, but maybe let's discuss later. No problem. So the first thing which we see here is like both policies have unsafe inline it. So it is actually useless, right? Because you could just inject a script tag with whatever you want, right? So this is actually really bad. But also if it would not have the unsafe inline, it would still be bypassable regardless of what. I guess the unsafe inline is still here because they can't get it work without it because it's really hard. So I wouldn't call it a bypass, maybe a common mistake, or maybe on purpose because you still have inline script on your web application and you haven't refactored it away completely, for example, for event handlers and this kind of stuff. So it takes a bit of effort, and if your application wasn't designed with CSP from ground up, it's hard, right? But it's definitely doable. So as Michele already mentioned, right, if you have unsafe inline in script source, you could just, as an attacker, inject something like that. Like if we would say, like, reflected XSS, like, breakout and then script alert, blah. So it's really useless, right? It's totally defeats the purpose, like the XSS protection purpose of a CSP. Yes, so the same holds true if there's no script source directive and only a default source, right? Because then the default source becomes effective for script source, and yep. Maybe a bit more interesting, but still very trivial. We saw it quite often that people just whitelist like URL schemes or star, right? So, I mean, basically you can, again, do almost everything, right? It's just a bit more complicated, right? So instead of like inline script, you would just source it from like any HTTP endpoint, HTTPS endpoint, and it will work as well. Or if there's data, right, you just create a data blob with the script you want to execute. Maybe if there's like a length restriction for the XSS, it might help to some extent, but it's pretty useless, right? Star as well, right? Star just means you can include anything. So the same is the case for object source. If you have a protocol handler or a URL scheme or a wildcard in object source, you can do like very similar stuff just with Flash files that execute JavaScript, right? So just briefly to the unsafe inline, we found about like 85% of the policies use unsafe inline, right? 85% of the CSP policies we were able to crawl on the web. This is like a substantial amount, right? Yes, please.
What's the percentage out of the overall that you crawled? What's the percentage of the websites that do use CSP at all?
It was like, what was 5%?
A little more. I think it's a little more than 2%.
Yeah. So,
of host names.
Host names, based on host names, not URLs, right? Because that's biased. Yeah. So. Here it becomes less trivial, right? Very often people do like default source, like very liberal to have like images or whatever, or they just restrict the script source, right? For example, this one is kind of strict, right? Just self. If you don't allow like user provided content or user upload on the same domain, it's usually okay-ish. But very often people forget to add default source or object source, right? So if you have a policy like that, an attacker could just include an object that does JavaScript, right? And then you give the object access to the site's JavaScript, and you can, again, do whatever you want in that origin. So, yeah. Also, I mentioned that already, if you whitelist self, I guess most of the cases it could be okay. If it's a pretty big domain, like with a lot of endpoint, like a lot of products or whatever, or if you, yeah, I don't know, if you have like an upload section or whatever, right, on the same domain, which is always a bad idea anyways, right, but just for the sake of completeness, it should be mentioned. If an attacker can, for example, upload a JavaScript file or something that looks like a JavaScript file, maybe CSV, right, then also self is not sufficient. Yeah. So let's continue with whitelists in general, right? So this is something which you see like really often. You have a policy and they whitelist a lot of domains, right? As we saw with Twitter and Gmail. The thing is, this is unsecure in many cases, especially many CDNs, which are like almost always whitelisted, serve files that can be used by an attacker to bypass the whole CSP. I mean, this is like not super news or fancy, but I guess some people haven't heard about it. So what you could do is, if whitelisted.com has a JSP endpoint, which is basically just, you know, a JavaScript response where you can control the, I don't know, first part of the response, right? So with that whitelist, an attacker, with that CSP, an attacker could include script source whitelisted.com/JSP and callback, and then as a callback parameter, he could put a JavaScript function, right? Or depending how restricted it is, even like a lot of JavaScript code as well. So by doing that, CSP will say, might jump to the next slide. CSP will say, yeah, sure, whitelisted.com is whitelisted, so I allow this transaction, and you're perfectly fine to source that from whitelisted.com. Whitelisted.com then will reply with the callback parameter and some other stuff, right? Usually some object blobs or whatever, right? And then for the page, it will look like if you would include a script from there, right? Because first thing is which is returned is like alert 1, and it will just execute. So many people maybe know that JSP endpoints are often somehow restricted in the character set they allow. So for example, like, I don't know, parentheses or whatever, they're sometimes blocked, right? Which is good. But this only mitigates this attack to some extent. Because there's something called sum attack. It's a same origin method execution. And basically, for that attack, it's enough if you control the function name to more or less you know, interact with the page as a user. So you don't have like full script execution, but usually you can do everything a user can do, right? So it's just like almost as bad or as bad, depending how sensitive your site is. So that would look like this, right? You would, for example, like have callback some button dot click, and you don't need any parameters for that, and then you would just simulate a series of clicks or stuff like that, right? So it's pretty powerful. There's a nice paper about it. If you haven't read it, it's really worth reading. Yeah. So for better understanding, Miki will give you like a quick demo of like how JSP bypasses work. Yeah.
Thanks, Lukas. This was great. So, yeah, JSP is a problem for CSP, and this is not very widely known. And we want to stress that this is a real problem, and this is a deal breaker. Even if you use not just full domains like a CDN, almost all CDNs embed at least one JSP endpoint. So this means you can't whitelist CDNs, right? This is as strong as that.
Yes.
And even if you want to whitelist a path, like a deep path, because you can say, I don't want to whitelist a full domain, I whitelist just jQuery. You whitelist the path, okay, you might be safe, but in a lot of cases, actually, even the API you want to source, for example, Google API, right, or something like that, might support JSON-P. And if it does, it means that you can't source it in a secure way, because you can always pass callback parameter, right, and have this that Lukas showed. So here I want to show, for example, with Google Maps. So here we have like our Amsterdam. This is a widget. This is dynamic. And it is sourcing maps.googleapis.com. See? Maps.api.js. This supports a callback, because a lot of APIs still do that. So when this is finished loading, it will call initmap, which is this function. OK? So what happens if I just... Sorry. What happens if...
You probably should set the content security policy.
Yes, no, it doesn't.
Liberal one.
Yeah, no. If I put alert in the callback, this happens, right? This is not dangerous, right? Because it calls alert with some junk, right? It's not dangerous. But if you have elements on the page, you could do element.click, and this would get clicked because the arguments passed to click just gets ignored, right? So this is just to show that like a very common API uses JSON-P, and you can't use it with CSP in a secure way. So for example, here, let's put a content security policy that just, let's just ignore this for a moment, that just whitelists maps.googleapis.com. OK, just a second. OK, let's try again with the Google Maps. Oh, really? Sorry about that. Oh, yes. And I have to also add unsafe inline.
Or the nonce.
Right. Yeah, we haven't introduced the nonces yet. Right? Yeah.
Yeah, but still.
OK. I also have to allow unsafe inlines for inline scripts, because I have an inline block, right, for initmap for this one, right? Let's just ignore the nonce for a second. Yes. So this works. I allowed maps.googleapis.com. But as I showed before, if I just script source HTTPS maps.googleapis.com maps API JS callback alert, see, I basically bypassed the policy, because here I could put my JavaScript.
So, yeah.
Yes. And here we go back to the presentation.
So yeah, I mean, it's pretty trivial, right? It's whitelisted, and the endpoint just replies whatever the user provides in the parameters, right? So you trust, yeah, you trust the whole endpoint, but it still serves like user controllable content, right? Also funny, right? Like if you use like Angular, or if you don't use it and you have like any whitelisted origin in your CSP that also serves Angular, your CSP is basically bypassable. I'm not sure if this is obvious or not to many of you. So basically what you can do is, right, let's assume whitelisted.com hosts Angular. As an attacker, you would just inject that script tag with Angular, and then you would do like a bit of Angular, right? You can, for example, do that. And this inline expression will get executed because Angular is loaded, right? The funny thing is, again, most CDNs provide you Angular, right? So whitelisting any CDN again is probably already enough to get it bypassed your CSP. This is already very powerful because you can do anything in the scope of Angular, right? Of the Angular thing. But many of you would say like, yeah, it's not a full script execution, so maybe this is like scam. But I mean, Angular is basically nice, but usually there's always sandbox bypasses, right? Angular doesn't consider the sandbox as a security sandbox, I guess. Although they're trying, there's like always a sandbox bypass for Angular, right? So, for example, again, you load Angular, and then you would just do like Angular application nj-click, and then you say like event view alert, right? And then if you click the element, the JavaScript would execute. We have another example in a second that combines Angular and what was it?
Prototype.js.
Prototype.js to get like execution without any user interaction. And there's also sandbox escapes for Angular that are a bit longer, that also don't require user interaction at all. So you see, it's getting pretty hard for having a whitelist that doesn't have any JSMP, doesn't have any Angular, and no user-controlled content and stuff like that. So it's getting thin, right? This is like for Angular, explained again. So again, the CSP allows whitelisted.com. It just says, oh yeah, whitelisted.com is allowed, so you can load Angular. And then, since this is just a script tag that sources something from an allowed domain, it's also allowed to execute, right? And this is the example with like AngularJS combined with Prototype.js. So you first do like the load Angular library, and then on top of that you load Prototype, and then you could do something like on curry call alert1. The on curry call will give you a window object, and then yeah, you can do everything again, right? All of this is actually coming from Cure53's mini challenge page. If you're interested in that, there are a lot of Angular bypasses, also CSP bypasses. Mario is doing a great job on like finding them, collecting them, and this is really cool. Yeah. Then this is something which is really interesting. We actually haven't been aware about that a long time as well, only when talking with Mike West, who is the author of the CSP spec. In a side sentence, he mentioned that this is possible. So you know that CSP allows you to also provide a path, right? So you could say, yes, these CDNs you showed us, they're all insecure. We just whitelist every single JavaScript file which we are loading, which is still crazy because you will have like a 2-page CSP probably, right? But assuming you could do it, right? If any of these whitelisted endpoints have an open redirect, you could bypass the path restriction entirely, which is really, yeah, not obvious, right? It was actually added afterwards to fix a privacy issue. So usually we would do something like that, right? whitelisted.com/JSMP callback alert. Of course, since we whitelisted not whitelisted.com, but whitelisted/totallysecure.js, this will not work, right? Because browser will say, yeah, sorry, but JSMP is not whitelisted, right? It's just the totally secure JS. So what we can do is instead we source the file from sitewithredirect.com. As a URL, we provide this one, right? The whitelisted.com with the not whitelisted path. And what will happen is the browser will say, yeah, sure, you can source stuff from sitewithredirect.com. And then it will see like, oh, there's a redirect. So I'll drop the path information because I have to do it. And then it redirects to some other path on whitelisted.com, which has a JSONP endpoint, returns to JSONP, and it's game over again, right? Which is pretty bad. So this was actually added as a response to Homakov's using JSON, using CSP for evil blog post, which is really interesting. And yeah, I think it's still part of the CSP3 spec, so we have to live with that. You cannot really fully rely on paths for security. So that's bad, right? So this is a lot of information, right? And usually developers, it's just too much for them to know. Also for security folks sometimes, right? It's like so many bypasses and kind of things we can do wrong. So we developed a small tool that just takes a CSP, that uses all the rules we found, right? And just gives you all the weak points and bypasses of your content security policy. And for example, like also tells you if you have missing directives or whatever. And then you can unfold it and you see like details. We found it pretty helpful internally, and we hope to release it soon. So, I mean, it's like not top secret or anything. So, just need to find time to release it. It basically covers all the rules we talked about and much more. And especially for developers, right? You can just put in the CSP and see like, oh wow, red, that's probably bad. I should do something else. Because it's very dangerous, right? Because like people rely on that, right? They come up with a CSP and they think they're secure, but basically they just wasted a lot of time, and in the end they end up with a, I don't know, just maybe it just takes the attacker a bit longer to bypass it, right? Just buying some time. So the thing is, as you saw, CSP is pretty powerful and it's like a great idea, but it doesn't really work in practice. And we actually want it to work because CSP has a lot of interesting features, and if it actually would be really amazing if we could get rid of a huge portion of XSS with CSP, right? So we narrowed down the problem to actually the whitelists. The thing is, if you whitelist the domain, right, it's like trusting a whole city instead of a citizen, right? Like there could be so many things, JavaScript files, other stuff on a whole domain or CDN. So it's actually not a real whitelist. It's more like, narrowing down it a bit, right? So we thought we probably should drop the whitelist entirely, right? And instead use CSP nonces, which were introduced in CSP2. So instead of whitelists, you would just nonce every script, and only scripts with a nonce would get executed, regardless if they're inline or sourced from anywhere else. The big advantage, right? You don't have to maintain the whitelist. So also for developers, right? It's incredibly hard to come up with a whitelist. And second, it's incredibly hard to maintain the whitelist, right? If some other developer adds something like another JS library, maybe the whole site breaks because they forgot to adopt the CSP. And I think this is also change the CSP, because I think this is also one of the reasons why CSP hasn't taken off, because it's really a lot of work to maintain, right? With nonces, it's a lot different because you can have the framework support nonces, and for example, like auto-noncing scripts, or whatever. And by that, if you nonce, for example, JSONP endpoint, it is fine, right? Because it's just the full URL that is nonce, right? The attacker cannot control it anymore, right? Miki will give you a short demo afterwards. So, yeah, we call it like nonce-based CSP. It's actually normal CSP, just without whitelists and nonces. There are actually some problems with that, but I think we have a solution. So the problem is, you can do nonce-based CSP already now, right? But it probably will break most of your site. Because, for example, the maps widget or other libraries, right? You put the first, you source the library, right? And then these libraries source other script files from some other place, right? And this is like very common for widgets and other stuff, right? So So for example, a pattern like that, the initial script is allowed, right, with the nonce. And what it does like create element script and sources some module for the library or for the widget from somewhere else. Or maybe it's just a init script, right, and sources the rest of the library from somewhere else. And very often it usually does that like with document append child s. So the thing is, the new dynamically created script does not have a nonce, right? So it will be blocked from executing. So it will break the whole widget. So either you can refactor all your libraries and widgets and try to have like big companies fix their stuff, which is fairly unlikely, or we can do something else, right? Which we will talk about in a second to fix this. But first, let's talk about nonces very briefly. So it is quite similar to what we already had. You have a policy, but instead of the whitelist, you have nonce some random string. It is really random. It should be really random for every response, because if the attacker can guess the nonce, he could inject a script with the right nonce and it would execute, right? But usually you can get this wrong without messing it up. Some people can mess it up, right? But so this one would be fine, right? Script nonce something would execute because it has a nonce. Yep.com is not on the whitelist, but that doesn't matter anymore because there's a nonce. What would not work is script source attacker.com without a nonce, right? If you would inject that, it would be blocked because there's no nonce. Same for inline scripts, right? If you inject the script tag without a nonce, wouldn't execute. Mickey will show you a quick demo about that to make it easier to grasp.
Yeah, so nonces look like a great solution. So basically, you just have to nonce everything, sourced or inline scripts, and only nonce scripts get executed, right? So the script that you put in your markup, the script you trust, right? But as Lukas said, there is a problem because most real-life scripts actually dynamically load other scripts, and the dynamically loaded scripts do not have a nonce. So basically, just the first one would be loaded, but what is dynamically loaded would be blocked by CSP. So very, very quick demo here. I put a policy with self and a nonce of random. And then I put like the Google Maps widget. Let's wait a couple seconds, and we see that it does not load, and the console complains that it refused to load a couple scripts, which are common.js, well, you don't see probably, but common.js, map.js, util.js, stats.js. These are all dynamically loaded scripts that Google Maps is trying to load, and it fails. But the first one, like this and this, got executed because they had the correct nonce. But what this tried to load, it has no valid nonce, so it is blocked by CSP. And we came up with a solution for that under the assumption that whitelists are insecure, but you could have trust in your own scripts, in the scripts you put willingly in your markup. And it is a nonce propagation method.
Oh, there was a question.
Oh, question?
How is that going to work if the attacker, the adversary will just see the nonce in the source code and include the nonce in his new script? So
Good question. So basically, the attacker will not be able to see the nonce because the nonce will be in the header, in the HTTP header, and it will be in the DOM, of course. But it will not be able to guess the nonce without having JavaScript execution in the first place, because it will not be able to see the DOM.
Yes, and it's
Or
the
the
client,
HTTP header.
like the victim is receiving the header, right? So the attacker doesn't see the header which the victim receives, so he does not know which nonce to put there in the first place, right?
maybe it doesn't see how hard it is to see the header, right?
Well, if you can intercept the wire
Well,
on the wire,
It's outside the attack
you would have
scenario,
to have
right?
an active interception, right? You could inject any JavaScript.
You could
then.
inject, exactly, JavaScript.
And if you
directly.
would just have passive and you would just see it and would add it in the next response, it would already not match anymore the new header, right? So from that, like that attack scenario, like you don't need XSS or CSP or anything if you can tap into the wire and return whatever you
But
want, right?
maybe you had something else in mind. I'm not sure we got your concern completely.
We can also
Okay.
talk
So basically,
afterwards.
you need JavaScript execution in the first place to read the nonce, right? And you can't get it. That's the idea.
Nonce has to be a dynamically generated nonce, 'cause
On the
Yeah.
server side, yes.
On the server side, random for each page load.
it's the same nonce, the attacker can
Exactly.
Absolutely.
replicate it.
And can replay. Yes.
Exactly. Think about it as an XSRF token. Exactly the
Absolutely.
same, right?
It's exactly the SRF.
It's exactly like an XSRF token just for script execution.
Yes.
Basically.
Yes.
I'm just getting the mic, just making sure that the people in the back can hear it too.
Oh, sure.
Are there any further questions? Just feel free to.
Anyone else before we continue?
Okay.
Oh, sure.
Just going to answer that. So it means that for every request, the nonce will change in the header and on each script tag.
Yes.
Yes, but it will be the same, right? The one in the header and yeah.
They have to match, but they have to
Exactly.
be different at each page load.
The browser just compares header with all the script tags, right? If that matches, the browser says, good to go.
Similar to CSRF, which the token is in the body and in the cookie and then just matches.
Yes, yes.
Yes.
Just that there's like no server-side validation afterwards, right? It's all happening in the browser, right?
Yeah. Actually, an XSRF protection with like cookie and
Double
thing
signature
is
cookie,
client side
yeah.
too. Yeah. So that's exactly actually the same. Yes. It's browser enforced. Yes. I go, right? Yep. Okay. Okay, so we propose a solution which is called unsafe dynamic, and it is a proposal in the draft of the next iteration of CSP, CSP3. According to unsafe dynamic, which might change name, we might see it in the specification with another name,
Allow dynamic, maybe.
maybe allow, because we are not super comfortable with the unsafe part, because it will actually make the policies much easier to deploy and also safer. But there is a pattern to follow. So the idea it will make a content security policy simpler to deploy for existing applications. And the idea you have a high degree of confidence in the scripts you load directly, but you have a low confidence in being able to come up with a secure whitelist, which is a very rational assumption, because we have showed, and we also show in a paper that we are going to submit, that basically if you use a whitelist, it is very, very, very likely that your CSP is useless. You are like 94% likely. And the idea is you have your script, which is nonced, like there. The script loads dynamically another script with append child, create element with append child, as Lukas showed before. And this will be fine. I mean, that script would load because it is loaded dynamically from a trusted script. This is as simple as that. But if you use another API, which is not a DOM manipulation, but for example, document write or inner HTML assignments, that would not work. Because these are APIs that are more prone to XSS, and also conceptually in the browser, under the hood, they are different. They are opening the document. A document write is opening the document, the stream of the document, and writing the markup. So we say it is parser inserted. This is something unsafe dynamic would not allow. This is very important because allowing those two would actually make it a little more unsafe.
Would really increase the attack surface, right?
Would increase the attack surface, right? But we also conducted a study, and we've seen that with inner HTML is not a problem for dynamically inserted scripts because you can't really add a script with inner HTML. You can do inner HTML script tag because this will not work. Well, you can with event handlers, but you can't directly. Document write, this might be a problem for some properties, but just for a very, very few. Unsafe dynamic will, as I said, allowed scripts created by non-parser inserted dynamically generated scripts, and will do something else, which allows backward compatibility. So it will allow developers to just add unsafe dynamic to their existing policy and make it secure magically, which is it discards the whitelist if present. So if there is a whitelist and there is a safe dynamic, exactly as we probably didn't say that yet, but if you have a nonce and you put unsafe inline together, unsafe inline gets ignored because you have a nonce.
This is just a fallback mechanism.
This is a fallback
for old
mechanism.
browsers who don't support nonces. They would get the unsafe inline and site would still work. New browsers who would support the nonce would just ignore the unsafe inline. Same
Yes.
for unsafe dynamic, right?
And we have an example about that in a few slides. So nonce, if you have a nonce, unsafe inline is discarded, and if you have unsafe dynamic,
Whitelist.
whitelists, thank you, whitelists are discarded. Okay? So this is how it will look. You would create a policy that is, in theory, just has to have a nonce. You need a nonce. And you put unsafe dynamic. And then you can keep whatever else you want. So you can keep your existing policy. And this will be secure because nonce random would allow all scripts to execute if they have the correct nonce. Unsafe dynamic will propagate the trust to dynamically generated scripts and will discard the whitelist if present. Unsafe inline would be discarded because there is a nonce. And everything else, HTTPS, self, cdn.com, would be discarded because it's a whitelist. And then there is unsafe dynamic. So I have a very short demo here. I showed already the nonce-based CSP. So this is exactly this one. Nonce, script SRC, nonce, unsafe dynamic, unsafe inline, HTTPS. Okay, so HTTPS allows, just to be clear, every script on HTTPS, but this is ignored because there is unsafe dynamic. Unsafe inline normally allows inline scripts, but it is ignored because there is a nonce.
And again, this is just for backward compatibility to older browsers. If
Right.
you have like a user agent switch and only serve like the policy to newest browsers,
You can just omit those.
you can just do that, right? But if you have the fallbacks, older browsers who don't understand the directives, they would just, execute everything as if there would not be any CSP, and you would not break old stuff, right? So
Which is important, especially if you don't want to rely on user agent sniffing, right? To
This-
provide
yeah.
different policies for different browsers.
unfortunately, CSP does not have versioning, so you have to rely on these fallback kind of things, which makes CSP a lot harder to understand, I think, right? Because I'm not sure how many of you knew that like nonce drops unsafe inline and unsafe dynamic will drop like whitelists, right? This is
It is a little confusing. So here I just want to show that the example we used before, Google Maps, with the correct nonce, works with unsafe dynamic. So the problem before, you remember, was that dynamically generated scripts were blocked by CSP. Now they are no longer blocked. And for example, I can put
Jump in the
my 3D view. I did not. Last time I tried this demo, I went in a canal. Yes. See? And this works perfectly. And this is secure. Because if you try, for example, to load a dangerous script or inject content, it will be blocked.
Yes, so compared to the example before, the attacker could not anymore inject script HTTPS maps API /maps API /js callback dangerous because he would not know the nonce, right? That's the difference. Yeah.
Exactly. Yes, please.
You said that the parser,
Thank you, guys.
Yes.
Yes.
Sorry, would you mind using the microphone? Was it? There you go.
What if you want to use inner HTML?
So usually it's a bad idea, right? Because it's very error prone. But if you want to use it, you could set the script to inner HTML, or maybe better to say document write with a nonce already, right? You could put, if you know the nonce, you can also add it there, right? And then it would still execute because it then has the nonce, but you have to manually propagate the nonce, right? The browser does not do it for you. This is a design decision because, document write in HTML, it is like a source of error, right? Like if you put any user controllable content to that, it's very likely that you end up with XSS. And this is exactly the point of CSP. You don't want to have that, right? And this is why it only allows, stuff created by an API.
So
Yeah.
You can't set scripts within your HTML. It would not work. So if you do this, it will not work. what you can do with inner HTML, you can execute scripts just by firing an event. So you would have to use something like this and then do on error alert 1.
Yeah. So in this case, right, it's not reducing.
work.
It's not reducing the usefulness
But
in general, right?
if you
Just
do
for
this-
attackers.
So you would not be able to do that in the first place. You should not use, and you cannot use inner HTML for injecting scripts directly. Right?
You could use document write.
Because it is, yeah, exactly. It would not fire. It would not be considered a script element.
Yeah. And if for some reason you really have to use document write and some, I don't know, markup blob with script, you could add the nonce here, right? Because if you like the author of the file, you probably can propagate the nonce yourself. And
This
the
would
attacker
work.
doesn't know about it.
Yes, but what if this kind of code is in the library you uses?
Yes, then you have a problem. Like if the library uses document.write to write script blobs, then it will break, and then, yeah, hopefully someone would have
Yeah.
will
Then
fix
the
the
library
library.
would have to be fixed.
Yeah.
But it has to be said that document.write is synchronous. So it is deprecated to use in a lot of situations. So unless you really want a synchronous behavior, so for example, for module loading, it might make sense because you want to load them in order. If for let's say async module loading, using document write is really discouraged because it would block the execution. It would create a global lock, and it would slow down your application a lot. So I would say that
Libraries are
modern-
not advised to use that, right?
Modern
in the
libraries
first
do
place.
not do that in the first place.
Okay, cool.
Okay, cool. Thanks for all the questions. Yes, so this is the fallback mechanism I was talking about. So with a CSP3 compatible browser, so for example Chromium, well, some of these, since it is a draft, some of these are behind experimental flags, but both unsafe inline and HTTPS are dropped because, as we said, HTTPS is a whitelist, so it's dropped by unsafe dynamic, and unsafe inline is dropped because there is a nonce. With a current, let's say, browser like Firefox or Chrome Stable, which is CSP2 compatible, and it supports nonces because nonces are in CSP2, basically unsafe dynamic would not be recognized. It would just be ignored because it's a token, it's a keyword it doesn't know. And unsafe inline would still be dropped because there is a nonce. If you have a CSP1 compatible browser, such as, for example, well, right now, let's say old version of Safari, like an old WebKit browser, it will not know what a nonce is, and it will not know what unsafe dynamic is. So it will be a no-op, basically. It will allow unsafe inline, so it means inline scripts, and from everywhere, HTTPS. So this means it's like not having a CSP policy, but it will not break. It will not break your application, which is exactly what developers want when they, and what, let's say, specification designers have in mind when they think about backward compatibility, right? Not to break existing applications. Browser support is a little fragmented, so the browser that implements most of CSP3 is Chromium. Then we have Firefox and WebKit browsers. Sorry, Firefox Opera. Opera uses Blink, which is the same as Chromium engine. It lags a little bit, but not too much. Safari uses WebKit. Safari very recently got nonce support. It is as recent as March of this year. Firefox does not support CSP2 fully, unfortunately. It does not support child SRC, which governs frames, and it also has a couple minor other glitches. So for example, for plugins and also serving the policy in a meta tag. Then there is Edge, which is just CSP1 compatible. It actually supports some CSP2, but it does not support nonces, unfortunately.
They're working on it.
So they are working on it. They are working on it. So it will probably be as Safari in a while. Okay. And then there is Internet Explorer, which does not support CSP at all. Okay. I don't know how much time we have left, but
5:30.
yeah. But just a couple slides to talk about our success stories. So we piloted Unsafe Dynamic on some complex web applications at Google, and we can say that we had a very, very good experience as developers and implementers. We dealt with teams directly, and the teams were really happy. So some of them already had CSP and were already dealing with the burden of having to maintain long whitelists and update them. So for example, a part of Google Maps had to periodically update the whitelist for loading the tiles of maps. So they changed the name, like the host name. And so they had, to avoid breakages in production, they had to know that, they had what to modify exactly, wait for the push in production, and so on. So they were super happy to actually switch to a CSP policy that would be as secure or more secure and does not need to maintain a whitelist anymore. So we deployed it on like 4 or 5 services. They have more than 7 million monthly active users. And we can say that it works out of the box for at least Google Maps APIs, Google Charts API, Facebook, Twitter, widgets, reCAPTCHA, and really the majority of the modern web. You can test it yourself if you have Chrome 52, so beta or Chrome beta or Canary, or if you have earlier one, but not too old, you could also enable a flag, which is web platform experimental features. And you can go to that site, CSP Experiments. We have a testbed there, so you can test that actually Unsafe Dynamic works out of the box with a lot of widgets and will make deploying CSP much easier. I think this is all for us, and this is our Twitter, this is our email, and this is hashtag, because we are not cool if we don't have a hashtag, and questions.
Question about maintaining the whitelists. You said that Google Maps don't have to maintain the whitelist anymore, but for the older browsers, I guess they do.
Yeah, so for the older browsers, we decided to just use HTTPS, so allow everything.
So yeah, the whitelist didn't provide much security in the first place, right? So why should you invest in the burden of having to maintain it any longer if it's bypassable anyway, right? So we just did HTTPS.
So they just deleted it completely?
Just yes. HTTPS as a fallback, right? So it would allow everything for browsers that don't support CSP3.
Because even if they were trying, and we were trying really hard, unfortunately, at least one of the paths we had to put there had a JSONP endpoint, unfortunately, and we can't really do without it.
Okay.
And it's not just Google; like a lot of applications have the same problem. So we can't name probably,
but there's like one exception where whitelists might work is if you maybe have like a sync domain, right, where you only put like free JavaScript files which you fully control. You don't need JSONP, you don't need Anchor or anything. Then it could work, right? But this is very hard if you have a big, complex web application, and it's probably not feasible for most.
You don't have to use CDNs too.
Yeah.
So can we praise them publicly? Do you think?
I guess, right?
Yes, I think it's a praise. GitHub did a really good job in actually creating a secure whitelist, and it is kind of the only.
Yes. So the whitelist one domain, and they just have like a couple of hand-selected scripts there.
Yes, really hand-put.
But yeah, unfortunately, it doesn't work for many other use cases, right? And yeah, so I guess we are going with the non-spaced approach.
Okay, thank you.
Could you only whitelist domains? Would it be possible to whitelist files from domains? So could you not just whitelist .js files and then have it only match
You can, but if you use a file that has a callback or JSONP endpoint, right, legitimately, it would still be bypassable. Or if you have any other point in a whitelist which allows an open redirect, you can downgrade from this like file path granularity down to domain granularity, right? So you can bypass it again. And it's incredibly hard to whitelist every single JavaScript file path you have in a big application, right? Because they change the versioning maybe. They might start loading other files from the same subdirectory, right? So if they get updated, you will have breakages, basically.
Exactly. I want to demonstrate this exactly what you said. So you see that the file I load is JS, API JS, but you see like this is not working and it is trying to load. Sorry, I have to also allow unsafe inline. Sorry. Sorry. So let's say you want to go down to the single file, right, as you did now. And you try to load, and you see, it's not working. It's also loading, I don't know if you can see that, but common.js. So, okay, I want to load this one too. So I add it. Like this, right? Common.js. Then you try again. Oh, there are more. There is util.js. There is stats.js.
So it
grows really
you soon will reach the maximum header size in HTTP, right? Yes. It's just like, this is like really getting big and hard to maintain, right?
Yeah, so for example, you decide, for example, here, maybe they're all in the 11a path. Yes, they're not. They're not. There are more. So you can't do that.
Yep. Yes?
Could you whitelist only portions or blacklist only portions of the JavaScript? Let's say document write and not accept it unless it's coming exactly for the two scripts. Or is there any ideas of going towards that direction? Because
we thought
reached, right?
Yeah, we thought about having like a more granular, possibility to whitelist certain APIs, but it gets ridiculously difficult, right? For developers, for maintaining it and everything.
But this is not about making life easier for developers, it's about making secure web, right?
Well, if no one uses it, right? If no one uses it, then you already have lost, right? If like CSP in the current state is so hard to adopt that this is a reason why not many people are using it, right? And
also, like creating a safe API, so a subset of what JavaScript allows, it is a great idea. It is what hardening does. But it is very hard to maintain that. So blacklist is impossible, right? Because, for example, there are at least 6 ways of doing eval. There is new function, there is eval, ECMAScript 6 introduced new ways, and so on, right? So you can't blacklist, right? Document write, there are many other ways of doing document write. Right.
Coming to the safe group of this or subset of the JavaScript that would be allowed generally, and then only whitelisting safe source.
Yes, but this means that everything had to be refactored in the web, right? So jQuery would not work, right? So.
I would never include jQuery. I don't like visiting websites that use it. That's, for me, that's loading tons of script just because somebody didn't want to learn JavaScript. That's mitigating security onto the user from the developer who is just lazy. And they've been inherently doing things wrong for decades now.
Yes, you have a point there. You have a point there. Just saying that the web is moving forward really, really fast, and we would love to have like a secure subset that is used everywhere.
Yes, I mean the create element is mostly secure if you can, as an attacker, cannot control the URL itself, right? Which is possible in very niche cases, but you would still like remove probably the biggest portion of the attack surface, right? And the other thing is, it's also not easy to convey browser vendors like to implement all these features of CSPs, right? Of CSP. And Unsafe Dynamic is actually surprisingly easy to implement, and we hope that this will help us to drive adoption, right? Like it doesn't really help you a lot if only one browser supports it. And maybe building on top we can iterate, right? Building on top of that we can iterate. But from my perspective, I think this would really give a CSP a second chance. And yeah.
I invite you all to tackle Miguel and Lukas during lunch. For any further questions you may have, please give them applause. And thank you guys.
Thank you. Thank you.